Hi everyone and welcome again to the SQL course. Let's go step by step, understanding what we need to do in each exercise and doing the solution at the same time. So exercise 1, we need to create a table named invoices with the following structure. Invoice ID, integer primary key, store ID, integer column that is not null, book ID, an integer column that is not null again, invoice date, a date type column, and price, a decimal 19.4 type column. Here, let's start with the create table command. We should create in the books and books dot invoices. And then we can start with the structure. Our structure is invoice ID. So invoice ID should be an integer primary key. Then we have store ID, which should be an integer, not null. We have the book ID, which is also book ID. Sorry about the difference in casing that we have here. Here we have casing with the underscore, and here we have what is commonly called camel casing. Sorry about that. It should be coherent between both of these columns. But as we've done the tables that we are going to connect here with different casing, it's better that we keep it this way, just to avoid confusion. So book ID with camel casing is going to also be an integer, not null. You can do, for example, instead of having here book ID, you can do book ID in this way. No worries. Just remember that when you are doing the exercise ahead with the join using this as a key, you'll need to have exactly the same spelling, okay, because this is case sensitive. So the upper and lower casing must be exactly the same. Now I need an invoice date. So invoice date, which should be a date. And finally, price. So price is a decimal 19.4, and I think that's it. Let me close this one. I'm not going to create this table again, so I'm not going to run this code, but if you run this code, you'll create an invoices table here in the books and books database. Okay, exercise 2, let's now insert 3 invoices into our table. So insert, I'm going to put here exercise 2, insert into books and books dot invoices. And I'll want to insert the following. So I'll want an invoice ID, a store ID, a book ID. Check that I'm inserting the IDs because I don't have auto increment in any of the columns, okay? If you don't have auto increment, we need to add them, or at least use them explicitly in the insert into. Then invoice date and price. Okay, cool. And now values, let's start with our values. So invoice ID 19994, on store ID 2, book ID 3, so 2, 3, right? I'm using the same order of my insert into. It's just a recap on what we've done before. Invoice date 1st of January of 2021, year comes first, in this case in the normal format, then 1st of January, and then $19, so $19, okay. I'm going to put it also in this way so that we can now do a comma and add a new invoice. And I'll go here, there you go, new invoice, and then also another one because we'll need another invoice. Second invoice, we have 1995, then store ID 4 on book ID 7, store ID it's 4 and 7. Let's see the date. So this was purchased on the 3rd of March of 2020. 2020, 3rd of March, at the price of $1.50. So $1.50. Next one is this invoice ID. So invoice ID 19996, store ID 4, book ID 15. So 1996, store ID 4, book ID 15, of purchased 5th of April of 2021. So 5th of April of 2021 at a price of 21.5. Okay, you can run this one and you'll check that your invoice IDs will look kind of like this. So books and books dot invoices. Okay, very cool. We have store ID, book ID, but now imagine that I would like to know what's the name of the store ID and the name of the book ID. That's exactly what we are going to do in exercise 3 and 4. So exercise 3. Now let's check. Perform the appropriate join to add the book name to the invoices table. Only add the common products between the invoices and the books. Now this last sentence takes us where? Takes us to an inner join, because we only want to add the common products between both of these tables. And this sentence also gives us a hint on what's the key that we need to use. In this case, common products. Products must be the key. What's the product? It's the book ID. Let's see here, for example, a.invoice ID, a.store ID. I'm selecting everything from the table on the left, and then a.invoice date. I could use a.asterisk, for example, to bring everything from the table on the left. Let me also do that for you to check. So I can do a.asterisk, brings everything on the table on the left, b. and I think it's book name. Cool. Now, from what? From the books, and our table on the left will be the invoices as a inner join with books and books dot what? The books table. And these books should be as b. Now what we can do is where a dot book ID, because that's the column that we have available on the invoices table, is equal to b dot book ID. This will give us the correspondent book name for each book ID that we have here in this table. In this case, the 3, 7, and 15, and of course here I'm missing an on. This is also cool when you see here this cross or flag means that your syntax probably incorrect. In this case, my syntax is incorrect because I'm here missing an on to indicate that these are the keys that should be used as connectors between the tables. So that's why I have that with a cross there that indicated me that the query was clearly wrong. And there you go. I know that this is Moby Dick and the Black Swan. So these two books. Notice that book ID 15 is not here. Why is not here? Because I'm doing an inner join and this book ID 15 is not on the books table. I don't know the name of that book. I don't have any metadata regarding that book. So in this exercise, we don't use it to go forward. Okay, because we are only asked to perform this join in common products between these two tables. And common things, let's say in this way, always takes us to inner join. Okay, so I'm going here, exercise 4. On top of the join performed above, add the store name to the result. Now we have a hint here, which means that we can stack joins by immediately adding a new inner join clause. I would like to have here also the store name. Do I need to do a new query to do this? No, I can stack joins one on top of the other. This is something that we didn't approach in the practical lectures because it's a more advanced concept, I would say. But even so, it's a good opportunity to introduce it here and also explain it. Okay, so let me pick up this one. So A, B, book name, using exactly the same join. I can now take this out and then use exactly the same syntax right below. Now I'll have a new table added to this join, added to the result or compounded to the result that we have right here, so this result. And what I can do is then to call a new table, and in this case my new table will be the stores table, and call it with a new alias, for example, C. And in the select that I'm using for these multiple joins, I can use c.store_name, which will be the name of the store. Of course, there's still a thing that we need to change. I'm going to ask you to pause the video and understand in this query, let me do this, in this query, what's still wrong and why this is not going to work yet. Okay, assuming you pause the video, let's go and check what's wrong. Of course, what's wrong are the columns that we are using to connect with the stores. There's no book ID on these stores, of course, and it doesn't make sense to perform the join with this table using keys that are present on the other two tables. So we need to use, of course, a join for this one. What we can do is then to use the store ID. So a.storeid is going to connect. Do you think it's going to be b.storeid? Of course not. It should be c.storeid, because the C is the alias that's referencing the stores table. And in this way we are compounding joins one on top of the other. Now if I run this one, you'll see that magically we'll have here the name of our stores, Pagey and Library. Okay, now let's go slow. So select everything from the table A, select the book name from the table B, the store name from the table C. Then we name our table A, which is the invoices. We do an inner join with the books table using the book ID. And then on that result, we do a new join with the stores table, naming it as C and using the store ID as the new key of the join. Okay, so in multiple joins, when we stack joins one on top of the other, of course, we don't need to use the same key. We can change the key that we are using referring to that new table. I could also do this. For example, I could take this join out, of course, but now I can't refer here the book name. So I can do this, and in this case, my book name disappears, of course, because I'm not joining with the books table. Now notice, as I'm not joining with the books table, the domain of my table also changed, because the book ID 15 is here. As the store that we have right here is available on the stores table, we were able to perform this inner join, but as soon as we had here a new join with the books, where the 15 is not in the books table, that disappears. Okay, try for yourself what happens when you do multiple joins, and why stacking joins one on top of the other is a great idea, and it's also a good way to do cleaner code. Maybe a bit confusing in the beginning, that's why I didn't go too deep into it in the lectures, but even so, this is a good opportunity for us to get familiar with this concept. Okay, so exercise 5, perform the appropriate join to add the book name to the invoices table, retain all the books that were sold, even if they don't have a name in the books table. So in this case, what we are going to do is pick up the same code that we have done here in exercise 3, I'm going to name it exercise 5, I only have to change something. And if I go to the question, retain all the books that were sold, even if they don't have a name in the books table. All the books means that I'm having a left or a right. What's the table that contains all the books, not only the ones that are in the books table? It's the invoices table. So if I go here, the invoices table is the A, so the A should be to the left. In this case, a left join. Running this one, we'll have 15, but book name as null. Why? Because this book is not registered in the books table. So exercise 6, we need to create a table named invoices new with the same structure as the invoice table. In this case, we are going to add a new column called discount, which should be decimal 19.4. So if I go here, I'm going to copy exactly the same code, exercise 6, and discount should be a decimal 19.4. That's it. And oops, of course, not only that, I also have to change the name of the table, of course. So if you run this one, I can't run it on my own because I already have these invoices new, but if you run this code, you'll be able to create your table. This is also something really common to do in SQL, creating tables back and forth. When you are doing some joins or in use cases, these are pretty common tasks. We need to insert two invoices into this invoices new table. So I'm going to do here, pick up the code from exercise 2, but in this case, it's going to be on exercise 7. So this first invoice is exactly the same as the invoice that we already have in there. So the invoice with this ID. Only difference is that we add the discount to 0. And here in insert into, add the appropriate discount column that we have here, and also invoices new. Okay, going to take this out and then add the new invoice. So new invoice is 1997 on store ID 2. So 1997 store ID 2 and book ID 1. So book ID 1 purchased on the 3rd of November of 2020. So 2020 November 3rd with a price of $2, and now there must be a discount of $1. Okay, you can run this one and your invoices new will look something like this. From books and books dot invoices new. So this should have quite this look with two invoices and of course a new column that's not in invoices called discount. So exercise 8, create a query result with invoices from the invoices and invoices new tables in the same table. Retain all duplicates invoices and all columns common to both tables. So I know that I'm going to need here exercise 8, and I'm going to need, for example, all these columns probably. Let's see if all these columns will be available. Select from invoices, and then we need what? An union all, because we want to retain the duplicates. And then I need to select the same from invoices new. Now there's a thing, the discount is not available in the invoices table. So I can take it out here, but I also need to take it out below because I need to have the same table structure in the union or in the union all. And now of course I need to name the database, don't forget about that, books and books. I've tried to run this without naming the database, of course, sorry about that. So there you go. Now here we can see, of course, all the invoices, even these that are duplicated. So this 19,994 or invoice ID with that number is duplicated. It has exactly the same information. We can solve that on exercise 9 because exercise 9 asks us to do the same thing, but only to collapse all these duplicate invoices into a single row. We just have to change something here in our query. I ask you to pause the video, check what should be the change that we must do on this query. Okay, assuming you've paused the video, we just need to remove this all from the union all. And now if I run this, I'll have only 4 rows because my row was collapsed. My duplicate row was collapsed into a single one. Okay, so we're almost at the end, and here exercise 10 we need to add a column discount to the invoices table, so to the original invoices table. I'm going to do here discount or exercise 10. This is also a small throwback to another section, so alter table books and books dot invoices, add column discount decimal 194. So we've learned this when we were changing the structure of our tables using the alter table command. I'm going to run this, and of course this is going to give me an error because I already have the discount in that table, but if you run it you'll be able to add this column to your table. Final exercise is also an interesting one. So on the result from exercise 8 and adding the discount column, create a new column in the resulting set with the discount divided by the price. Name that column price discount. Let's see how we can do this. So I can use or compound on this information of the exercise 8. I'm going to go here, exercise 11. And now I need to add the discount as the query asked. Okay, now let's look at both of these tables. Okay, so we have here this discount and the price. Of course, for the discount that we've only added after creating the table, we'll have null because we didn't insert these values into the original invoices table, but we have the discount for the other ones. Now what is indicated in question is that we need to create a column, a new column, with the discount divided by the price. Now we know how to create new columns based on other columns in a SQL table, or at least in a select statement, right? So we just go here, use discount divided by price. And we know that we can name this column with an alias, as we've learned in the first section of the course. I know it seemed a long time ago, but this is what we've learned in the first section. So discount underscore price. Now a curious thing is that if I run this as is, I'll have a problem because the structure of the tables is not the same. Well, I can solve that using exactly the same calculation on the table that will be union to this first result. And now what I can do is have this discount price column based on this calculation. So as we are doing a union operator, of course we need to have the same structure, but that doesn't restrain me from creating all the columns that I need right here, just like we've learned in the past sections when we were creating things on the select statement. Okay, so this statement is really super powerful because here you can create most of the things that you want regarding using the current columns, and by using a union, you just have to state the same thing in the select of the table that you are going to union, of course, to make the tables have the same structure. So as long as you know these small bits of information about the instructions in SQL, for example, the union all means that you need to union two tables that have the same structure, then SQL is really, really flexible. For example, you can do a group by, even a query with a group by right here, and then you can union it with another group by that has exactly the same structure. And in that case, you'll stack two group by results. That's super cool, and that's something that is supported here in SQL. We finished the combining table section. This is a really important section for you to understand how you can combine different tables in SQL, either horizontally by joins or vertically by union operators. I hope this was clear to you. If there are some things that you still aren't sure about these concepts that we've been learning, drop me a message. I'll be super happy to help you and support you on your learning. I hope you are enjoying the course so far. I'll see you in the next section.